Hello and hi everyone. I am Nur Atika binti Muhammad Azman and I will explain about intake process and filter.
Hi, I am Amira binti Azmi. I will explain about expression in the compressor. Thank you.
Hello, I'm Naashkin Desa and I will explain about the cleaning process.
Hi guys, my name is Nurain Fitrode. I will explain about cooling process.
Hi guys, I'm Safia Basira and I will guide you about first distillation process.
And last but not least, my name is Ariz Zahab and I will tell you about second distillation process and how to store it. Thank you.
Today we would like to explain the simple way about the separation process by using cryogenic principle in distillation process. What is cryogenic? Cryogenic is the study of production and behavior of material in low temperature. While cryogenic air separation is the most preferred technology for producing this material as gases and or liquid product and supposed to be most cost-effective technology for high production rate plants. In today's market scenario, all liquefied industrial gas production plant make use of cryogenic technology to produce liquid product. As we all know, in our air surrounding consists of raw material such as oxygen, nitrogen, argon, and also noble gas. For your information, these three major components in air in chemical technology industry need to a lot of oxygen, nitrogen, and argon. Air separation has become a process integral to many manufacturing process. The largest market for oxygen are such as in a primary metal production, chemical, and gasification. For nitrogen in liquid form is used in application ranging for cryogenic grinding of plastic to food freezing. Argon, the third major component of air, find uses as an inert material primarily in welding, steel making, heat treating, and in the manufacturing processes for electronic. To know detail about this process, let's focusing on our procedure. Thank you.
Composition of dry air is approximately 28% of nitrogen, 21% of oxygen, 0.9% of argon, and the others are the noble gases together with the dust. Oxygen, nitrogen, and argon are required as industrial gases in large quantities and with a high degree of purity. Therefore, processes have been and further developed to produce these gases through the separation of air. For the first step, all of the composition of air will move along into the intake column. After all of the composition of air already in the intake column, and they are ready for the next process. Ambient air is sucked in through a filter and compressed to approximately 6 bar. Before compression, the air taken in is first cleaned of the dust particles. Filter process used to remove contaminant element such as dust from the air to achieve high purity of air. All of the component of air can move along the filter except for the dust. This is because only the pure air is needed for the next process. I know Atika and I will explain to you guys about material balance inside the air intake column. So this is value for the feed intake. This is value for the composition. This is a value for the molecular weight.
So first of all, we have to multiply each component with molecular weight and sum all to get total weight composition, that is 28.9590 kg per kmol. After that, we have to calculate the total flow rate by dividing the feed intake with the total weight composition. So after we get the total flow rate composition, that is 149.3929 kmol per hour, we need to calculate the flow rate for each component. We take the value for the component and we multiply with the total flow rate. So we get the flow rate for each component. So after that, the air will move through the filter and the value for air is remain unchanged, and the filter will remove dust as a contaminant.
The filter air is now compressed to approximately 6 bar. A large amount of heat is created through the compression. The air is therefore pre-cooled with water at this point. During the air liquefaction, our work is based on knowledge that gas heat up during compression and cool down during decompression.
I'm going to explain to you about the air circulation in the compressor. Okay, the objective of this process is to obtain the pure gases, which are argon, oxygen, and nitrogen that are needed in the chemical industry. For example, nitrogen for making ammonia, oxygen for welding and casting metal, argon for manufacture of metal. Okay, in this distillation column was divided two sections, which are rectification head at the top of the distillation column and a stripping at the bottom distillation column. Okay, in the distillation column, separation occur when one of the component reach its boiling point and vaporize to the top of the column in front of gases. Okay, the other components stay as liquid in the stripping section. Therefore, the air is needed to be compressed to change the air phase from gas to liquid, so that the pure gases can be obtained at this end of this process.
During the cleaning process, the air is clear of any impurities such as carbon dioxide, water vapor, and helium, which must always be removed to satisfy product quality specification. There are to be removed before the air enters the distillation portion of the plant. The portion is that where the very low temperature can make the water and carbon dioxide to freeze, which can be deposited on the surface within the process equipment. There are two basic methods to get rid of water vapor and carbon dioxide, which can molecular sieve and reversing.
After the compressing process, we will proceed to the cleaning process at the cleaning chamber, where the impurities gas will be removed at the bottom of the column. As you can see, and the gas that we need, that is oxygen, nitrogen, and argon, will be placed at the top of the column. Okay, the value of the inlet process is 4323.625 kmol per hour. Then after the cleaning process, the value that gas we need is 4321.884 kg per hour. Then the balance of impurities gas is 1.741 kg per hour. That is the gas carbon dioxide, neon, and others. So the total inlet is equal to the total outlet. Then the gas will be moved
Cooling is a method of dissipating heat. It works by making the object to be cool have a larger surface area or have an increased flow of air over its surface or both. The air will be cooled by the counter-flowing gases oxygen, gases nitrogen and argon gases in the main exchanger of the rectification column until liquefying temperature of the air. Because the gases which make up only liquefy at very low temperatures, the purified air in the main heat exchanger is cooled to approximate -175 degrees Celsius. The cooling is achieved by means of internal heat exchange, in which the flows of cool gas generate during the process cool the compressed air. Rapid reduction of the pressure then causes the compressed air to cool further, whereby it undergoes partial liquefaction. Now, the air is ready for the separating column where the actual separation takes place.
The distillation column uses a boiler to vaporize the liquid gases for separation process. However, in this separation, this process cannot use the boiler since the temperature below 0 degrees Celsius. Therefore, the process cooling chamber instead of a boiler to separate the component. Then, the composition of oxygen, nitrogen, and argon remain unchanged since the cooling process just to cool each of the components nearest their boiling point. Because of that, separation of the component does not take long in this distillation column.
About separation in first distillation column. So, after cooling process, the air consists of nitrogen, oxygen and argon still remain unchanged for their composition and flow rate. Why? Because cooling process just to cool down the temperature follow cryogenic principle. So, the flow rate of nitrogen plus oxygen plus argon is 4321.884 kilomole per hour. How to obtain the flow rate for each component, right? So, we need to multiply composition for each component with total flow rate. So, for nitrogen, the composition is 0.78. For oxygen, 0.21. For argon, 0.009. So, when we multiply this composition with total flow rate, and we can obtain flow rate for each component. After cooling process, the air in liquid form, which is nitrogen, oxygen and argon, feed into distillation column 1, and the distillation column 1 was set to nitrogen's boiling point, which is -195 degrees Celsius. When the nitrogen's liquid achieve this temperature, the nitrogen's liquid will vaporize and suck out into heat exchanger and compress into liquid and before store in storage tank. Okay, the flow rate for nitrogen liquid that suck out is 120.476 kilomole per hour. In order to obtain this flow rate, we need to divide feed intake of nitrogen at the after cooling process with nitrogen molecular weight, which is 28 kilogram per kilomole. So, meanwhile, the oxygen and argon still remain as a liquid at the bottom distillation column. So, the composition change because the nitrogen suck out at the top of the column. So, the new flow rate is 29.327 kilomole per hour. Oxygen and argon will flow into second distillation column for further separation.
The distillation process is continued with the second distillation in the second distillation column by using this oxygen and argon in liquid condition. So this distillation process is same with this one, but the condition in this second column is set to negative 185 degrees Celsius. So this temperature is same with argon boiling point. So when this column achieve this temperature, and argon gas will vaporize and will be sucked out from this column. Therefore, the oxygen is still maintained as liquid. It is not achieved its boiling point yet, so it will be directly stored as liquid oxygen. For filling or storage purpose, all this distillate product is stored in a liquid form before it will be distributed to the consumer. Thank you.
As a conclusion, the objective of this mini project was achieved, which we want to explain in detail about air separation. The air separation process follow cryogenic principle. C. The production of desired product needed at very low temperature. The distillation column is using in order to separate the three major components of air, which are oxygen, nitrogen, and argon. The three major components are stored in liquid form before supplied to the consumer. So, I hope this video will help you guys understand clearly about the air separation process. Thank you.